Hello there, Algebras, and welcome to your Chapter 2, Lesson 2 notes on creating dot plots. So let's review our measures of center, look at and analyze a dot plot that is done for us, and then use that information to help us make a dot plot and try to identify some of these measures of center, mean, median, mode, in our dot plot so we can kind of visualize what's happening within our dot plots. Okay, so let's start with some review of our measures of center. We've got our mean, which of course is our average. We're going to call that x bar or refer to it as x with the line over it. Our median, it's MED, according to our graphing calculator. It's the middle data value in our set. And so these two, the x bar and the median, those are the references to what spits out of one var stats in the graphing calculator, so we can combine those two things in our heads so we know that those are each other when it comes to the full word and the graphing calculator. The mode, the graphing calculator doesn't give us the mode, but it is the data value used most. It could be more than one data value that falls under a mode. It could be no data values are used more than once. And the range is the highest minus the lowest. Okay, the highest minus the lowest. That would be max minus min, giving us our range. All the values that we are including in our data set. Let's start by looking at a dot plot that has been done already. So here is what a dot plot looks like. A dot plot literally has a dot that represents every single data value in a set of data values. So if we look, this is the delay times for 60 Big Air flights during December 2012. Here's our dot plot. These delay times are in minutes, so 30 minutes, half an hour, 60 minutes, a full hour, 90 minutes, an hour and a half, 120 minutes, 2 hours, just to kind of give a little bit of that. Now, we're going to consider 3 questions, and these are 3 questions that I want you to take 2 minutes to think about after I read these 3 questions for you. So, I'll read these 3 questions. You'll pause this, look at the dot plot, and consider these 3 things as we look at the dot plot to see if you can answer these before I come back and answer these. Okay, so let me read them first. What do you think this graph is telling us about the flight delays for these 60 flights? Okay. Can you think of a reason why the data presented by this graph provides important information, and who might be interested in this data distribution? Last one. Based on your previous work with dot plots, which could be nothing, this might be the first time, but just consider any previous information. Would you describe this dot plot as representing a symmetric or a skewed data distribution? And this might be the first time we are visualizing that, so that might take a second. But I want you to pause this and analyze these 3 questions using this dot plot, okay? So pause it right here. When you come back, we will talk about what I think the answers to these 3 questions are. Okay, see you in a sec. And we're back. Let's consider, what do we think the graph is telling us about the flight delays for these 60 flights? So the graph is telling us, well, we had a lot of delays. If we look just visually, we are really drawn to a lot of delays between 10 minutes and like 45, 50 minutes, even 0 to 60, right? So the majority of our flight delays were less than an hour. So I think that's what it's telling us. The majority of flight delays were less than 60 minutes. Which is also 1 hour. I think that's what it's trying to tell us. Think about it. Out of 60 flights, this is where the majority of our delay times were. The other thing I look at this with is out of 60 flights in December 2012, only 2 were on time. No delays. So the two big takeaways that I kind of had here is, well, okay, the majority of the delays are less than an hour, but like almost none of these flights were on time. 2 out of 60. 2 out of 60 flights were on time. And that might be an important point to make, don't we think? Okay, well, can you think of a reason why the data presented in this graph is important? Yeah, do I want to buy a ticket to Big Air if 2 out of every 60 flights are on time? Not really, right? You need to consider your logistics. Flights taken in December, let's be real. There's a lot of really big holidays in December that we are probably purposefully going somewhere to be with someone for a specific event. And if I can't plan on this flight being on time, why would I buy it? Okay, so like the logistics of the situation. And if your flight's not on time, and let's say you're flying to be with your family, well, someone's got to pick you up at the airport, right? You're not taking your car with you. So you probably have to get picked up to the airport to go to the place that you're trying to go to. That's all in consideration when you're booking a flight. And so if we can't be on time, we need to consider what's the approximate delay issue that we might have. You know, the mode here is 16 minutes, 15 is right there, and then they're right next to it. So the mode here is 16 minutes for our delayed flights, okay? But that's still, this is 60 flights here. There were up to 2-hour delays occurring out of these flights. That's, when I'm thinking about that, I have to consider logistics. So who cares about this? Me, the consumer, right? So the consumer might care about your track record. If you're delivering what you say you're delivering a flight that leaves at 8 p.m. No, it actually leaves at 8:30 p.m., right? If I am the CEO or the board of this company, I want to know how we're doing. And I want to know who's in charge of making sure we don't continue to have this many delays. If this is me, I want to know that we can be relied on and that the consumer is going to purchase our product, because that's how I make money. That's how the board makes money. And so those are people that want to consider this. You know, one of the things I've noticed with my mom flies a decent amount now when she goes down to Florida. And so one of the things that I've had to consider is family looking at flights. And when am I going to have to be available to pick her up at the airport or bring her back to the airport so that she's making it back and forth safely? And so family and friends are people who would want to know this information about you. Are you safe? Where are you? Are you okay? So just a few people who may want to be interested in what's going on in the company for Big Air. So that's one of the things that dot plots allow us to do, is visualize something that on paper is just 0 minutes, 0 minutes, 5 minutes, 5 minutes, 10 minutes, 10 minutes. But we now visualize it and we can see where the majority of the data is falling. Based on our previous work with dot plots, or just a general rule. Would you call this skewed or symmetrical? And if you're thinking about it, do this. Yesterday, we had a picture that showed us what a skew looks like. That's skewed. And we call it skewed right because the tail trails off to the right. So this is skewed. Now, had that bump been in the middle and you got a little bit on each side, that is symmetrical or normal. This is skewed right, where your tail trails off. Okay, it's a great first look at a dot plot. Let's create some ourselves. So if we flip over, we've got a data set. We got some pet owners. Students from River City High School were randomly selected and asked, how many pets do you currently own? The results are recorded below. All right, River City High School, let's see. Okay, I'm going to divide this into kind of sections for myself. 1, 2, 3, 4 people said they own 0 pets. Okay? Over my 0 on my number line, I'm going to place 1, 2, 3, 4 dots in a vertical line up above 0. Each dot indicating the data value of 0 for this particular student that was asked how many pets they have. Now you'll notice that we're about to put a lot of 1s on this dot plot, and this number line didn't provide us with that, which is a poor choice for a number line for this, but halfway between 1 and 2, we're going to put a 1, and I'm going to keep filling in my odd values halfway between my even values, because I do have odd numbers of answers in this survey. So now that I've filled those in, let's count how many people said they have 1 pet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people said they had 1 pet. So this means we have to put 10 dots above the 1 heading up vertically, but you have to be very careful because horizontally they need to line up with the dots we previously put over 0. So we have to know that they're at the same level, and we line them up horizontally and vertically. So there's my 4 dots over 1, and now I keep going. 5, 6, 7, 8, 9, 10 people had said they have 1 pet. 1, 2, 3, 4 people said they had 2 pets. So now again, lining up horizontally with the previous ones and vertically over the 2. 2 people said they have 3 pets. Line up horizontally with the previous, vertically over the 3. Okay, only 1 person had 4 pets. Okay. That's probably the easiest lineup we've done so far, right? Oh, 2 people have 5 pets. 2 people have 6 pets. Lining up horizontally and vertically so we can see across very easily. 1 person has 7 pets. Oh, these last ones are 1 each. Oh, a little tail trail, huh? 9, 10, no 11, and then a 12. Now, let's think back to the actual question asked, right? How many pets do you currently own? Do you count fish? I wonder if this person who said 12 counts fish, because if you're just thinking about cats and dogs and hamsters and ferrets, like that's an awful lot of those mammals living in your house, a lot of extra fur. Okay, so my question there is, can we all assume that we all answered that the same way? Does everybody think of fish as pets? You know, well, I used to tell my husband that we didn't want any more living things in our house because I also have to like feed and water plants. Like that's something that I have to take care of, right? And so like, does that fall under that category if it's something that we're taking care of? So that's considered a pet? I mean, you just have to like know where the line is. And do you think that everybody interprets that line the same way? I don't think so. I don't think that everybody is interpreting that question the same way. It's a little bit up to interpretation, don't you think? So be careful on that. That's something for your future when you really study stats, is like how to ask a question that people know how to answer too. So we're going to calculate the mean, which of course is X bar, the average, and then we're going to mark it on our dot plot. So this is where we grab that graphing calculator and we press stat, we press enter, and in L1 we want to put our data. Now this is challenging when you have a data set like we do, where it's 1, 2, 3, 4 zeros. So you have to do, okay, 0, enter, 0, enter, 0, enter, 0, enter. So you got all 4 of those in there. Now you got to put 10 ones. Just be very careful about that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That does take us to our 15th data value, which is 2, and then you got 4 total 2s. It gets a little easier after this. So 4 total 2s. Now it's 2 3s, 1 4, 2 5s, 2 6s, then 1 of each of these last ones. So 1 7, 1 8, 1 9, 1 10, and 12. Notice this is now asking me for my 31st data value that I do not have because this was a set of 30 data values. Okay, so 30 data values here. All right, here we go. Let's press stat, arrow right to calc, and enter for 1 var stats. We did put our data in L1 as our list name, so we can keep that list and just press enter right on down the line. Our mean is 3.2. Now, is that a reasonable number of pets to consider? Not really. How can you be 0.2 of a pet? Okay, so here is where my mean goes in compared to everything else. It's not actually one of the data values. Now, if we look, more than half of the data is between 0 and 2. And yet my mean is up here. What do you think happened there? Well, clearly we had a skew to the right. This tail to the right dragged my mean away from the middle data value and away from the mode, right? So let's just look down in our data set that we were given here and look at what the median was. So the median was 2. So in here is where the median is, the very middle data value. And we can very clearly see that the mode is 1. That's what I love about a good dot plot, is I can see who's used the most visually right off the bat, and my eye is drawn to it. So for median, we've got 2, and for mode, we've got 1. Okay. So this data set does have a mode, and it is 1. So this is the ultimate question when it comes to a data set. What do you think a typical number of pets for a student at River City High is? Do you think the median is the most appropriate measure of center? Do you think the average is the most appropriate measure of center? Do you think the mode the value that appears most. What do I think? I think it's the median. I think when you have a skewed data set like we clearly have, the median is the best measure of center because it is an existing data value and it is in the middle of all of the other data values. When you have a skewed data set, the median is the best choice for measure of center, for middling our data. If you have a normal data set, no skew, all the data is in the middle and there's tails on each end, that's when you can use the mean as your best measure of center. Okay. I would like all of you, because we're going to save the standard deviation piece for tomorrow, for the next lesson, I would like all of you to work on Chapter 2, Lesson 2 homework. Create your dot plot. Interpret the dot plot I gave you. Ask me questions if you need them. Remember, normal data values, normal data sets, mean is your good measure of center, the average. Skewed data sets, your median is your best measure of center. Okay. Use that graphing calculator. Let me know if you need to borrow one. Good luck, my fine friends. I do not think you will need it. I do not think you will need it, but let me know if you have any questions. Bye, Algebras.